Smoke is mostly fine particulate matter that is harmful to human health and impairs visibility. This is why monitoring smoke from both prescribed fires and wildfires is important. By knowing smoke concentration trends, you can decide if a change in burning operations is needed, or you can keep affected communities informed of increasing particulate levels for health reasons during wildfires. Forest Technology Systems, FTS, has developed a GOES satellite transmitter add-on for the MET1's eSampler. The eSampler GOES kit provides real-time measurements of fine particulate matter from smoke. The GOES satellite sends data to a computer system at the National Interagency Fire Center, NIFC, in Boise, Idaho. The data can then be retrieved from the Western Regional Climate Center website. This program will teach you how to use the eSampler GOES kit. You will learn components to bring to the field, sighting the eSampler GOES kit, setting up the eSampler, setting up the GOES transmitter, setting up the eSampler parameters, retrieving data, and disassembling and packing the kit. Let's look at the components of the eSampler GOES kit. It consists of a tripod and crossarm, an eSampler with an internal gel cell battery, a PM 2.5 Sharp Cut Cyclone, a TSP or Total Suspended Particle Inlet, a 120 volt power supply, and a junction box. A GOES transmitter system consists of a GOES telemetry unit, a GOES satellite antenna, a wind speed and direction sensor, and an ambient relative humidity sensor. Other items included in the kit are the quick sheet, a UTC conversion chart, and miscellaneous tools. You will need to provide an extension cord. There are several things to keep in mind when placing the eSampler GOES kit in the field. Place the eSampler several miles downwind of the smoke in areas of greatest interest, such as communities or protected areas. Select a secure site with line power. Make sure the site is a good distance away from obstacles, such as tall buildings, large trees, and cliff walls that could block the eSampler's airflow. The site also needs to be away from dirt roads and industrial sources that could affect the eSampler's particulate readings. Finally, the site must allow the GOES antenna an unobstructed view of the sky. Set the tripod up by removing the 3 pins and unfolding the legs. Reinsert the pins. Slide the eSampler onto the top tripod tab. Attach the ground wire to the nut on the bottom of the eSampler if it hasn't already been done. Insert the bolt through the ground wire. Then insert the bolt through the bottom tab of the eSampler and through the tripod. Hand tighten the nut. The front of the eSampler needs to be facing true north. Now, stake the feet of the tripod down with metal stakes. Remove the dust cap from the eSampler inlet and put it in a place where it won't get lost. Attach the PM 2.5 Sharp Cut Cyclone onto the inlet of the eSampler. Attach the TSP on top of the PM 2.5 Cyclone. Mount the power supply onto one of the legs of the tripod. Next, mount the backing plate to the GOES transmitter with the 4 supplied bolts. Slide the GOES transmitter onto the tripod and tighten the U-bolt onto the bottom. Attach the GOES antenna by sliding it onto its tab. Secure with the push pin. Screw the antenna cable onto the bottom of the GOES transmitter. Attach the crossarm to the top of the tripod with the wind sensor mount facing east. Attach the alignment hub to the bottom of the wind sensor. Install the wind sensor to the crossarm with the weight pointing true south. Insert the tail feather with the fin aligned vertically into the side of the sensor, and tighten the Allen screw with the small Allen wrench. Remove the lock screw that is located under the weight from the sensor and put it in a place where it won't get lost. Now attach the wind sensor cable to the sensor and then to the bottom of the E-sampler. Line up the key notch, then push and tighten. Secure the extra cable. Connect the power supply cable to the E-sampler. Connect the GOES transmitter cable that is labeled Data to the E-sampler. Then connect the junction T-box to the E-sampler. Connect the GOES power cable that is labeled TX to the junction T-box. Finally, attach the RH sensor to the west end of the crossarm. Lock the clamps. Connect the RH sensor cable to the junction T-box. Power to the GOES transmitter is supplied from the E-sampler's gel cell. Remove the battery cover from inside the E-sampler. Connect the gel cell battery to the battery leads, red to positive and black to negative. Slide the battery into place with the ribbon draped over the top. Replace the battery cover. Tie up any long, hanging cables with Velcro straps. Plug the E-sampler's power supply into an extension cord, and then plug it into an outlet. When the GOES transmitter is powered up from the gel cell, it will automatically go through a system check. Let's check that the GOES transmitter is operating properly. Inside are 4 indicator lights. The Sync GPS indicator will illuminate while it's acquiring a GPS fix and synchronizing its clock to UTC time. The indicator will turn off when these are completed. The data indicator will illuminate 2 minutes past the top of the hour while it acquires data from the E-sampler. It will shut off 1 minute prior to transmission. The Transmit TX indicator will illuminate for about 3 seconds while it transmits data to the satellite. The fault indicator is used with the diagnostic button. By holding the diagnostic button for 2 seconds, the fault indicator will blink once if everything is okay. If there is a problem with the GOES transmitter, the fault indicator will blink twice. This means that the transmitter is no longer sending data to the satellite, and the transmitter should be returned to the FTS for repair. When the E-sampler is powered up, it is ready to start sampling. If all the parameters have already been set up, just press Start Sample. Then Yes. Sampling will begin once it finishes its auto zero and span. This will take several minutes. If the parameters haven't been set for your location, you'll need to go to the menu screen to check the parameters. Let's go through the setup options on this eSampler to check the parameters. The up and down arrows move the cursor to a menu option. When the cursor is positioned on a menu option, press the Menu Select button to select this option. Once a setup option has been selected, use the left and right arrows to toggle, and the up and down arrows to change the settings. To start, let's make sure there isn't any old data left in the memory. From the main menu, select Memory. Press the white button under Clear. Bring up Data Logger and press Clear. Then Yes. Now move the cursor to Setup. Press the Select button. Select the clock function. You need to set the eSampler's time in Coordinated Universal Time, or UTC. You'll find a UTC conversion chart inside your eSampler Go's kit. Use the right arrow to move the cursor and the up and down arrows to change the date and time. Press the white button under Set to save your changes. Now move down through the Setup menu to set the following parameters. Average period to 60 minutes. Concentration, set range to 0 to 1. Concentration units to milligram per cubic meter. Set the K factor to 1. Now set the sampling mode to continuous. Skip alarm contact. Heater control, set RH set point to 50%. Self-test, set period to 24 hours. Communications, set DAC range to 1 volt. Baud rate to 9600. Skip station ID. Engineering units to metric. Finally, press the Escape button 2 times to get back to the sampling screen. Press the button under Start Sample, then press Yes to begin sampling. The eSampler Go's kit sends data via the Go satellite to a computer system at the National Interagency Fire Center, NIFC, in Boise, Idaho. To retrieve data from your eSampler Go's kit, go to the Western Regional Climate Center website. Here's a map with the currently deployed monitors. Scroll down to see all the monitors that are deployed. Click on your monitor number to retrieve the data. Click on Data Details in the left column. Adjust the dates for the time your monitor has been collecting data. Click the Submit Info button. The data is automatically put into an Excel spreadsheet that can be saved to your computer. Other formats are available for retrieving data in the left column. You can bring up a 7-day graph of the data or pull up daily or monthly data. Now, go back to the home page. Under About Smoke Monitoring, you'll find the quick sheet for the eSampler Go's kit, a UTC conversion sheet, and information on how to order the kit. If the eSampler screen has gone to sleep, press the right arrow button to wake it up. Press Stop Sample, then Yes. To properly pack the kit, refer to the packing photographs that are included in the smoke monitoring installation packet. Here are a few things to keep in mind. Disconnect all the cables and pack separately. Use the flathead screwdriver to open the clamps on the RH sensor. For the wind sensor, reinstall the lock bolt. Remove the tail feather from the sensor. The wind direction tail feather is stored in a cardboard protector and placed behind the foam in the case's lid. When you remove the TSP and PM 2.5 cyclone, remember to place the dust cap back onto the eSampler's inlet. When you disconnect and remove the gel cell, put the plastic terminal protectors back on the battery. To pack the eSampler and GOES transmitter, remove the backing plate from the transmitter. Then place the eSampler and GOES transmitter side by side in the box, placing cardboard between the two units. Place all the miscellaneous hardware and tools in their plastic bags. Pack the rest of the equipment securely. Finally, the tripod, crossarm, and GOES antenna get packed in the tripod case. Smoke particulate monitoring kits can be ordered at your local fire dispatch center. Request NFES 5840. If you have questions about the eSampler GOES kit, you can contact the Missoula Technology and Development Center at 406-329-3900. Thanks for watching.